for that. This is an open meeting. We've broadcasted it and even put it up on the Open Meetings Act. So we will have some public comments and some questions. And but with that, I'm just going to turn it over to Adira. Jordan, you want to go ahead and kick this off? And let me just say one more other thing. Staff probably has some questions, and if you want, I'll just set on the technical part of this. We'll have, if you got questions or if you already submitted those to that, but if you want to speak, we'll just do this where everybody can hear what we're talking about, okay? Jordan, it's yours.
Great, thank you, Mike. Everybody can hear me? We're good. I know we had some technical difficulties last time we were here. We'll stand up real quick. Jordan Quarry with our Dura engineers at Oklahoma City and the project manager for Mesa Water Project. We've got our team with us, Camilla Lang, our project engineer and resident hydrogeologist, and then Crystal Kowalik, our client services manager, as well as two of our project engineers. Give a little wave. Josiah Cornell and Connor Wadington. Both OSU grads, depending on how you guys feel about that. We will get into this. So, a little history for those of you that are just new getting to these meetings with us with the City Guyman and Guyman Utilities Authority. So, Mesa Water Project has been an ongoing, I think we're in our 5th year now for the multi-phase design and construction for a new well field located about 7 miles north of the city. And then the ancillary conveyance, raw water conveyance, and then storage and finished water treatment to bring it here to the city of Guyman. This project's been a priority, I know, for city staff and the public as well, making sure that we continue to meet the city's demands, right? And hopefully fight off future water restrictions and things like that. Water is the lifeblood of what's going on here with the city of Guyman and the surrounding community. So phase 1 that we completed back in January was the confirmation test well program, where we drilled 7 test wells out in the prospective well field. And what that data provided us was that there is quantity and quality of groundwater out there to meet the production demands of somewhere between 3 and 5 million gallons a day to bring to the city of Guyman. So phase 2, the production well field improvements, which is currently in the final design stages and awaiting permitting with DEQ for construction, that is the construction of those production well fields within the proposed well field and the collector lines and surface completion to bring that to a point where we pick up with phase 3 outside of the well field. So here in phase 3, we've got the water delivery system improvements. This is 60%. At 60%, we're showing all major components for that final water conveyance and transmission back to town. So we'll thumb through here. That might be a little small for you guys to see up there, but what we've got is the Mesa well field, like I said, about 7 miles northeast of the city. That'll be our new production well field with 6 of those 7 test holes being developed for future, or that final production of groundwater to go back towards the city. So phase 2 leaves us off here at Road R, and we will pick up under this construction package for phase 3 here in right-of-way with the raw water transmission back to the ground storage tanks and booster pump station at what we're calling the Mesa station before final transmission to the city's existing water system here on the northeast side of the city at Perlman and 24th Street. So this is about 6 miles of large diameter water line, ground storage, and booster pump station to get that water from that Mesa well field back to town. So what we've got here is it's a high-level representation of the hydraulic grades of the existing Guyman water system with the addition of our new Mesa water system. So the city primarily and solely runs off groundwater. We've got the existing wells shown here at their hydraulic grade elevations where they feed the city's elevated and ground storage tank booster pump station configurations before being finally pushed into the city's distribution for customer use. So here as part of Mesa, we've got our well field and then feeding the 2 new ground storage tanks and the Mesa station before getting pumped back here into Guymon. So taking a look at what that raw water transmission line, that water line looks like feeding the ground storage tanks here at the Mesa station. This is an 18-inch HDB, high-density polyethylene. It's a type of polypipe or fused plastic pipe, which is going to be conveying that raw water or that undisinfected water that's produced out of the new Mesa well field. This is its termination here, feeding the tanks. We'll find that this 18-inch is going to take us back in right-of-way along Road R. All the way back, we're looking at about 18,000 feet of this water line, taking us all the way back to where we left off at the phase 2 portion from the well field. So this 18-inch will connect to that 18-inch water line that we left off at phase 2, and that'll complete our raw water transmission from that what's produced as part of the well field to fill those ground storage tanks. So at the Mesa Water Pump Station site, this is 60%, so we've got the major components shown here. We've got a dual tank system, 2 ground storage tanks at 850,000 gallons for a combined total storage of about 1.7 million gallons. This will hold that 3 to 5 million gallons that we hope to see come out of that well field, and it'll be suctioned by the booster pump station for final push back to the city system. So here at the station, we'll have disinfection system as well. Those are not included as part of the 60% design, but we've got a little bit of empty space hanging out here. So that's under preliminary design right now. That'll be the disinfection facilities that'll turn that raw water to finished water, that potable water that we can then push into the city system for customer use. So taking a look at the tanks, these will be 2 concrete ground storage tanks. They're 70 feet in inner diameter and about 30 feet tall. These tanks will have the inlet configuration being fed by that water that's produced out of the well field and then disinfected ahead of the tanks for potable water storage, and then it comes out the backside of the tanks to be suctioned out by the booster pump station and then boosted back to town. Taking a look at the tanks themselves, these are a plan and section of what those ground storage tanks look like and the associated appurtenances for the inlet, the outlet, overflow, drain, safety cage, ladder, anything you can think of that's going to go as part of those working appurtenances on the tank. We've got those shown here, as well as the roof plan. So those concrete tanks are special manufactured by a certain number of manufacturers here in the the nation. There's about 6 manufacturers that specialize in that type of concrete tank construction. So those will be installed at site. So as part of the construction activities within Mesa Water Project, we've also got our stormwater pollution prevention control plan that's dictated by the state, so it'll avoid that surface runoff pollution that'll be adjacent to the project area, so we'll mitigate that. And then moving into the structural components. So as part of the structures, we've got a foundation plan here for the booster pump station site as well as the ground storage tanks. Those will be poured in place foundations at that booster pump station location, as well as some other small structural foundation pads related to the disinfection building and electrical components that are out there. So taking a look at process mechanical diagram, this is a diagram that shows us what this flow path looks like from the well field making its way to the Mesa booster pump station. So we have our raw water coming in here. We have our disinfection system that's converting it to that finished water or treated or potable water. Before filling our ground storage tanks, we've got a bypass here as well that's dictated by the state, that we have a bypass there in case we need to take a tank down, which will then be fed from the tanks to our booster pump station configuration. This booster pump station is designed as a 4-pump system, 3 duty, 1 standby. In the event that we need to take a duty pump offline, we've got 4 pumps in there. For future consideration, we've shared with the city, they've got a 5th pump in there, or at least space for a 5th pump. as they consider adding some additional water from future sources or what have you, since this will be the booster pump station that's located furthest north in their system. So it offers the city some flexibility should they find additional water source to put into this Mesa water station. And then coming out as finished water on the back side, this will be our final transmission through the 24-inch line back to the existing water system. Let's see, this will load. There we go. So as part of the booster pump station improvements, we've got a package system design here, and what that means is we've got this system will be fabricated off-site of the Mesa water system and be placed on-site as a complete and ready system, or something we like to call plug and play. So with a prefabricated or packaged booster pump station, assembly will be off-site, placed on top of the foundation pad, and then hooked up for the adjacent exterior piping and what have you. So this is a great way to minimize construction costs on behalf of the city. We've got a system that is efficient and solely manufactured in a plant or facility that we can, speed up the efforts to get this water to town without having to build a brick and mortar booster pump station here. So. Let's see. So outside of the station, we've got an electrical power plant. TCEC, we've got a meter set here for the new station location. Since I understand we've got minimal electric out there right now, so we're showing a new meter as well as a new transformer to feed this site for the Mesa booster pump station. From there, as part of our electrical plan, we've got the cables and power distribution across site. We'll have power to the distribution, or the disinfection facilities, as well as the ground storage tanks for the level sensors that are also located inside of those tanks. Moving into our instrumentation and control scheme. So as part of these improvements coming online, we have instrumentation and control equipment and strategies to tie it back to the existing water system and how it'll operate as part of the control scheme to get that water from the well field through the Mesa booster pump station and back into the city system. So taking a look at the wells, this will load for us. We've got an instrumentation and control strategy here for a level indicator for the water levels inside the wells, which will read back to the city's instrumentation and control strategy so they can monitor what's happening as part of the well levels, static versus drawdown, or that dynamic water level, what pumping water level that water level looks like inside each well. In addition to the flow rates, what's leaving each well, and the pressure discharge. So these wells will be tied back to the new ground storage tanks. So the ground storage tanks will have the level indicators. We can move to those, which will read a high level and a low level. That the wells will be tied to is when we hit low level in those tanks, those wells will be programmed to turn on. At least the pumps inside those wells, and we will push water back to the system. This will create an efficient system to where we're not running those wells 24/7. We're able to allow some downtime inside of that well borehole and efficiently feed those tanks to keep water moving through these new improvements. So taking a look at the station, the instrumentation control strategy here is when those tanks are full or operating, we've got the booster pump station tied back to the control strategy in the city. So the current operating scheme inside the water system here in town is it's read off the elevated storage tank. So when those tanks get low, booster pump stations kick on, make sure we're feeding water to the tanks so that we always keep water pressure and storage throughout the system to continue that that uninterrupted service to customers throughout the entire system. So this station will read similarly that when the water levels get low in town in that elevated storage tanks or water towers, this station will be told to kick online. It'll pull water from the ground storage tanks located next to it or adjacent to it at the Mesa water station and push that water into the city system. And I think we're at the end of our plan set. So that is 60% as part of the Mesa Water Project Phase 3 improvements, like I said, for the raw water transmission line, the tanks, and the booster pump station, and then that final transmission back to town. At this 60% milestone, we're looking at a construction estimate right at $21.5 million, and looking to be at final design for February of 2026. And then we'll go through the same process like we are right now with the phase 2, with regulatory review compliance with the state, and get issued construction permitting to start bidding and construction early spring. So, Mike, anything else you can think we want to add as part of phase 3?
I think you pretty well covered the technical aspect of that. I do know I might want to just open it up for staff. I think there's some discussion on storage tanks. We had some preliminary talks earlier this morning about metal or iron versus cement. Do we want to kind of maybe just touch on some of the
Absolutely.
versus
You can.
of? Yeah.
For sure. So as part of the ground storage tanks for a water system, you've got two choices at this size of tanks. So these are three-quarter of a million gallon tanks, so 850,000 plus or minus. We can either do steel tanks or we can have concrete tanks. And the city of Guymon has both. They're both effective means for water storage as part of a public water system operation. Our recommendation as part of this system was for concrete tanks at the 850,000 gallons at this size range. So steel tanks are typically most effective at sizes a little bit smaller than this, somewhere 750,000 gallons and less. We see that the construction, the capital cost for steel tanks is much lower than concrete tanks. And they can be an effective means for water storage. But unfortunately for steel tanks that are the welded steel, they require interior and exterior coatings against corrosion resistance. So concrete tanks, the advantage for these guys is that you're not required to do interior or exterior coating. That concrete has the chemical composition to resist any type of corrosion. The way the steel, unfortunately, we've got to keep up with the coatings and operation and maintenance like that. So that's a benefit on our behalf. So for this size, these concrete tanks are going to be more economical for the water storage. We're asking them the capacity that we're designing for, and that the city doesn't have to keep up with the more tedious operation and maintenance for interior and exterior coatings on those steel tanks. And unfortunately, in our experience as well, we've seen Crystal Kowalik was the engineering manager at Oklahoma City, the Water Utilities Trust, for 19 years. What we see too with steel tanks, the larger they get, the harder they fall, unfortunately. And when they do breach that corrosion resistance, we'll see that when they fail, it can, unfortunately, it doesn't happen linearly. So it'll happen exponentially. All of a sudden, you have a failing water tank. And concrete tanks can unfortunately fail too, but when designed right, you've got a monolithic structure. These concrete tanks are shotcreted, or they've got precast walls, and they're wire spun and then shotcreted over. So what you end up with is a monolithic structure that is going to resist failure by those small crackings or weathering away, that normal wear and tear as you see over the 50 to 75 year life that you'll get out of these tanks. So that was our recommendation to the city, that we go with concrete tanks for system reliability, resilience. The city and the Guymon Utilities Authority can install these ground storage tanks and be sure that they can continue uninterrupted service and not have to do unnecessary operation and maintenance over time on the other type of tanks like steel. So I think that hits our points there, Mike. But
another thing I wanted to just back up is for about 5 minutes ago, you were stating about the tanks itself and the level indicators there in the Mesa part of that. Only when, you have to keep in mind, I'm just going to address this to the group, you have to keep in mind we've got 15 existing wells right now that will continue to be supplying water to the city of Guymon. And they pump directly into our system and fill these water towers up. And only when those towers cannot, or the 15 wells can't keep up with our demand, did I hear you say that is when it sends the go signal to the water wells in the Mesa field?
So the new well field will operate in tandem with the existing system, but what it'll do is it'll relieve the pressure on the existing wells. So Can I get a little louder there? Sorry, guys. So the existing wells that we have here in the city of Guyman, in order to meet the demands that customers have for their water use and needs, these wells operate fairly continually. So what we like to see in a typical well operational strategy is we've got dynamic time and we've got downtime. So you've got dynamic time when that well's kicking on, the water level drops because it's getting pulled and pumped out, and we're feeding the system like we should. And then, but unfortunately, what happens when you've got to keep water pushed through a system? You're on the supply side of the wells, but then you've got demand. You don't see that downtime because you constantly need to be pushing water to meet the service of your customers and your constituents. No one wants to be without water, right? It should be a right, not a privilege. So what Mesa Water will do is it'll offset about 3 to 5 million gallons and offload that demand that's currently on the existing wells located in town. So what the city will be able to do with this new water that's being pushed into the water system is be able to take their wells, take that stress off the existing wells. So they'll still be operating, but just at a little bit lower time, because no system is meant to operate continually forever and all time. That's when you see yourself in emergency scenarios. You know things break, unfortunately. Things need maintenance and routine, but the city and the Guyman Utility Authority, you guys have done a phenomenal job in making sure that water is kept into the system and being supplied to their customers, for safe drinking water and consumption. So what Mesa Water will do is just offload the stress and the tax that is on the existing system by being able to keep up with the city's demands and be able to provide that continual service.
Let's go say one more thing here, and hope it opens up some discussion between myself and you. Theoretically, the Mesa Water, if it does come on, we've talked about getting an additional 3 to 5 million gallons a day. Now, would that be coming directly from the Mesa?
Yes.
Okay.
Yeah. So.
But what if we can still provide 3 to 5 million gallons here in Guyman itself? So, I mean, right now we're at 6 million, or really not 6 million. We can't do 6 million. I think right now we're at about 5 million gallons a day. That's on a heavy day. Mm-hmm. And so if we can pump that with our existing wells, theoretically we're not going to be pulling 3 to 5 million out of the.
Correct.
Yeah.
Correct. What it does is it gives the water supply that is providing water to the city of Guyman some what we call in the industry some additional risk and resiliency. So right now, where the Guyman system is operating is that what is pumped out of the wells gets taken up by what we call demand in the water system. It gets taken up, used as drinking water or potable water. It's used by customers. So when you see a water system that's operating close to that 1-to-1 ratio, you're in trouble. Because what you want to do is have enough extra water in your water supply in those events where you've got heavy flow, say you've got, we've got a big line break, or which hopefully doesn't happen to anybody here. You've got a high fire flow scenario where all of a sudden you need some extra water. You want to have enough resiliency and supply on your production side from your wells to be able to continually feed and provide uninterrupted service to the city of Guyman. So we do expect to see somewhere up to about 5 million gallons that we can produce out of the Mesa well field. But that does not mean that we plan within our lifetimes to push 5 million gallons every day for all time. And not run the wells that are currently here as part of the existing system in town. What it does is, and I think we've seen a decline in the water production from the existing wells that we have here in the city, and that's due to a lot of factors. And typically, it's due to age of the wells. So when you push those wells hard here in town, like we do to meet the demands of the city system, you start to lose efficiency. Equipment wears down and things like that. So you're not getting the same bang for your buck or production out of those existing well fields here in town. So what Mesa allows the city and the city of Guyman constituents and customers to do is I would think rest easy at night. You've got some additional water supply and backlog that can continue to meet the city demands. Just because we have that extra 5 million gallons potentially coming from the Mesa well field doesn't mean that it's going to be used every day. It just provides the city with that risk and resiliency to continue to meet demands for future planning.
Thank you. I like that little banner we have there. And another thing I want to touch on too, and you touched on it too, the amount of water that we pumped the last, I've been in it now for two whole summers. Our pumping capacity was sometimes, and correct me Josh, anywhere from 95 to 96, 97% of our pumping capacity. We were hitting that threshold pretty regularly. My biggest fear was what if we had a major line break, or what if we had a downtown fire or something like that. We would not have enough water to put the fire out. So, and that's kind of why we've been kind of hustling around trying to find water. There was another thing I was wanting to run by you all on the pump station itself. We touched on it. Did you visit with our team today about the expansion of the prefab pump house with that fifth pump? Or?
We have not had a chance to talk about it in detail with the
right.
city. Yep.
Yeah. Okay. I guess what I'm trying to say is we're looking into the future, because there's other properties out there close to there that we're going to be exploring for water. So we're building this pump station, which is going to be located just straight north of the Cactus Station, where possibly we could go in one more pump, or maybe another booster pump.
Exactly. Add another pump for future expansion to that station. And what we're hoping happens with that is as the city continues to investigate additional water supply for future planning, right? As part of Mesa Water, it kind of feels like we're playing catch up. The city, you guys have enough demand now that you need additional water supplies to meet your demand, and we know that's only going to grow, right? Hopefully, the population comes or more industry comes, and water demands only seem to increase over time. So, as part of the city's planning to investigate additional water supplies, we've considered adding that space for a fifth pump inside the station, so that in this near future, as the city investigates getting more water supply to the station without having to go build another station or look for additional improvements, and that construction cost to the city is they have the ability to look at retrofitting that new station we're putting in now to continue to meet that additional water supply and demand scenario. By adding that fifth pump, we don't need it today, but there's a good chance we may need it soon in the next 2, 3, 4, 5 years. And hopefully that's a cost benefit we see to the city to be able to continue to expand existing structures, since we're spending the capital to put it here under Mesa Water, so, and minimize what we have to build out as part of the future.
Staff, do you have anything? I'm not going to put you on the spot, Mike. Steve? Everything, okay, we've submitted everything we needed to the region.
Talked about a few things. So
Okay, good. Okay, great.
And Mike, if I may, all those gentlemen back there, part of the city staff and Government Utility Authority, they turned in their homework early. They sent comments back. Yes, so we've had a chance to talk as well at length on this. So I know they're ready to get this moving as well. And so.
Well, and like I said, when we opened up, we most generally do this via computer. But I think it's just now's time to start, because we're getting close, and I know there are probably a lot of questions out there, and I'm willing to, when we conclude this, meet over the corner. We'll answer any questions you got as best as I can. I know Mr. Stevens just come up to me and asked me a couple of questions, and I appreciate that. Sound like me, he and I is kind of almost on the same page there. So he owns land just to the north there. Possible of looking into water coming from that piece of property with this expanded booster pump. So you were thinking way ahead of I was.
You're thinking ahead. No, that's what
anyway,
it is.
It is open. TCEC, I see a whole bunch of TCEC shirts out there. First, I want to brag about you. Thank you for being a big part of this. Every time we have a question, you're there, and we appreciate that. There's always somebody on the call when we do have a technical question, so I appreciate that. So,
likewise, thank you, TCC.
Do we have a timeline? You want to go over the timeline with this 60%? When will it be 100%?
So we're looking to be at final design here the first week of February 2026, and
Okay.
then we'll go through state and regulatory review for construction permitting the following months, and should be going out for public bid and construction by late spring.
Will that be on just phase 2 or 3?
So that'll be for this phase 3. So where we're at right now as part of phase 2, building out the well field, is we're sitting at final design and getting ready to go to the state for the construction permitting, which will take about 2 months.
Yeah, so phase 2, what we're talking about is the actual production well.
Yes, yes, sir. So
And as everybody sits in this room, I'm just going to go ahead and say it, it's still a crapshoot. You know, there could be water there, and we're pretty sure that we are. All of our technical tests, I mean, still it's up to the good Lord himself. He's going to say, yeah, there's water there, there's not water. But until phase 2 is initiated and we do a test pump, we will not know exactly how much water we have.
absolutely, yeah, that's the way, and that's why we give that range, is that we anticipate based on our hydrogeological investigations, the test holes, that, you know, building out those test holes into public water supply wells or production wells, we believe we can get a yield range between 3 to 5 million gallons a day. God willing, you get 5, but I know we'll be happy with 3, so.
Yeah, we'd be happy with 1.
We need the water, absolutely, but that is part of the risk in water well drilling, is we don't know until we pump, until we build it out in the pump.
Okay. Anything else from staff or anybody? And there again, this is an open meeting. We have a short agenda here. I think we've met all the Open Meetings Act. I'd be willing to stay here for another 10, 12 hours if we want to huddle up afterward. GCEC, do y'all have anything you need to go over? I think there might be some. Have you talked to them about the expansion of the...
I have not had a chance to catch up
Okay.
with the TCC gentlemen, but we'll be ringing you guys here in the next couple of days. We'd like to get on the calendar, we give you an update what's going on as part of this package, and see what we can do, getting on the schedule, putting meters out there that are, you know, in line with the construction improvements. So if you guys want to hang around for a minute, we can chat after this.
I just kind of, I knew about it just today, but about the expansion of that, which will definitely change the line coming into it. So y'all kind of need to have a little head start on that.
Well, yeah, absolutely. We'd like to keep you guys in the loop now that we've got a final decision what that station looks like with the additional pump. So.
Some about KWs and probably talking about trucks for a while, but I guess they were. Keith, you got anything? Yeah. Okay, great. Sheila, got anything? We might want to touch on just a little bit of what Sheila has been working on it's the cost. And we were blessed to have the state of Oklahoma through their appropriations through the state of Oklahoma. In their line item budget, give the city of County $20 million for this project based on a whole lot of economic factors. And I'll just be honest with you, the biggest factor was the industry we have currently here. Seaboard does use probably 50+% of the water, 60, and they do pay for it. I heard yesterday we give Seaboard a free ride, and we don't. They pay an industrial water cost like all the other industries do. And you did hear the engineer say it's a $32 million project?
Yep, it's 32 in total, so this phase is 21.5 million.
So that doesn't really compute with, we have 20. I was interviewed by Channel 10 in Amarillo a couple of days ago. I did say that if the remainder would probably be on the backs of the utility buyers. But the reason I said Sheila, about 2.5 years ago, when we first got notified by the Department of Energy, there was some money available, and immediately went to work trying to procure that type of money. And we were notified about a year and a half ago that we were in the running, I like to use that, for $17.5 million, which was good, but that wasn't in our pockets. Then all of a sudden we had an election, and the White House turned around just a little bit, and politics got in the room, and that 17 million was froze. Department of Energy just come out with a press release about 2 weeks ago stating that money through the Department of Energy has been evaluated by the Trump administration, and a lot of that money, let me go back a little bit what that money was about. There was supposed to be a major transmission line come through this whole country, and we were notified by the Department of Energy that there was some money there. If it come through your part of the world and it caused any adverse effects to your community, you had a chance of getting some grant money that would try to help offset that. Well, first thing I come to mind is what if we had, I'm just going to pull a number out. There might not have been this many people, but what if we had 2,000 workers come in to spend 2, 3, 4, 5, 6 months? We don't have enough water for that. And I thought, well, let's just throw a grant at them. And Sheila wrote up a grant and submitted it, and I'll be darned, they bought it. They bought it as fair and square because it would have been an adverse effect on Texas County and especially Guyana, because if we had that many construction workers come in trying to put in a transmission line connecting the east and the west coast, electrical, we just couldn't do it. We just couldn't do it. And so they awarded that grant. I think they also awarded about $50 million to the Guyana Public Schools. So that's still kind of that was kind of a short story to a long story. But when the House there in D.C. Changed from the Democrats to the Republicans, everything was kind of frozen. I get that. So we still don't know. The last I'd heard, that Oklahoma was the only state still left in the running. And they said Oklahoma. And we are part of Oklahoma, so we're not banking on it. We're not banking on the 17.5, but until it's deposited in the bank at the local banks we got our money in. I still stand firm the utility customers will have to absorb the remainder of that cost. So that's all I want to talk about politics on that part of it. Anything else, technical-wise?
I don't think so, not at this time. I know we'll be meeting with the appropriate teams here this afternoon and then over the course of the next many, many months.
Well, I encourage you, if you don't get an invitation to every 2 weeks, and it's the new technology, you sit there and look at the computer, and we talk to every 2 weeks, 2 o'clock on Wednesday afternoon. And we go over a lot of things. So I urge you that if you want in on that, I'll send you an invitation. If you got a computer, I guess you can do it off your phone. I've seen people tag in or they're just on their phone. So, and sometimes it's real boring, but it's kind of what we do.
And Mike, as part of those meetings, we issue meeting minutes as well. So if you are not keen to join in person, then you can be added to the email blast as well.
Yeah.
To keep up with regular updates on the project.
Sure.
Doing.
And any questions now on the technical part? Connor? You haven't said nothing. Okay. But I do appreciate Madura coming out. You come out more than I thought you was going to come out, but I appreciate that. So anyway, with that, we'll just be over with. And if you want questions, I'm wearing an orange shirt. Come up, we'll visit. Is that fair enough?
Thank you all.
Thank you all.
Thank you. Yeah.